Inverse trigonometric functions. I want to review first trigonometric functions. And remember, what we have here is the unit circle, and the circumference of a circle is 2 times pi times radius. So radius of the unit circle is 1, so it's 2 times pi times 1, or 2 pi. In other words, all the way around here is going to be 2 pi, which is what I've got here. Halfway around is pi, and a quarter way around is pi over 2. Three-quarters around is 3 pi over 2. So, and also with this, we also can look at the xy coordinates. And where I have 3 pi over 2, that is, by the way, 60 degrees. If we use x squared plus y squared equals 1, because this hypotenuse is 1, we'll go to pi over 3 here. If we want to know the x coordinate and the y coordinate from this angle theta here, well, cosine equals adjacent over hypotenuse. Writing is terrible with this little pen. I apologize for that. And we know the hypotenuse on a unit circle is 1. This radius of 1 is the unit circle. So this is the adjacent to theta. And if I go 1/2 here, then I can figure out what this is through the Pythagorean theorem. Because a squared plus b squared equals c squared. And my c squared is my hypotenuse. That's 1 squared, which equals 1. And if I want to know my a is 1/2, I square it, 1/2 plus b squared, and that equals 1/4 plus b squared equals 1. Subtract 1/4 from both sides, I get b squared equals 3 over 3 equals 3/4. 1 minus 1/4 is 3/4. And then when I'm done with that, square root of both sides, and that's the square root of 3 over the square root of 4, which is simply the square root of 3 over 2. The square root of 4 is 2. And that's how we get our y coordinate. And this is the opposite right here. This is the opposite of theta, opposite of our hypotenuse. So this is 1/2, and this is right here. This is the adjacent. This is the opposite, and that opposite is a sine, square root of 3 over 2. So basically, my x's are my cosines, and my my y-axis is my sine. So nothing we haven't done before. Now, when we look at inverse trigonometric functions, we're really just reversing where we have the radians with the outcome of being the x coordinate, the y coordinate, x coordinate for x, y coordinate for y. Cosine of pi over 3 is 1/2. And that's 60 degrees, by the way. Sine of pi over 3 is square root of 3 over 2. Now, if we go to the cosine to the negative 1 of 1/2, we're just reversed everything in order. Or the sine of 1/2 square root of 3 over 2 is still pi over 3. And this cosine negative 1 or sine negative 1, which we use in our calculator, is also known as the arc cosine or the arc sine. And then the arc tangent is found by, very simply, if the tangent is sine over cosine, tangent of 3 square root of sine of pi over 3 over cosine of pi over 3, that's square root of 3 over 2 over 1/2. So the tangent is 3, and that's square root of 3 over 1. So the tangent of pi over 3 is square root of 3. And that should be tangent of 1/2. 3 would equal, misrotate here, over 3. Sorry about that. It can be written as arctan right here. Pi over 3 equals I mean, arctan square root of 3 is pi over 3. All we're doing is reversing the x and y axes here. And I want to review the vertical line test. Remember, both of these lines here, and this is x equals y squared on the right and the left here. These are both equations, but they're not both functions. A function has to have pass vertical line test only touching one point. The one on the left here, this x equals y squared, touches more than one point, so it's not a function. The one on the right is a function. And in terms of trigonometric functions, such as sine waves or cosine waves, let's look at y equals cosine x. This is a function. But cosine negative 1 to the x, the arc cosine, is not a function. It can pass through infinite areas. But what's interesting is if I do have upper and lower bounds, I can set up a y equals cosine function, as you can see in the right here. It is a function with a boundary of negative 1 pi to 1, 0. So function within certain bounds, no different than it could be a function in this middle one here, from here to there, or from there to there. But it has to have bounds on it. And I'm going to show the reason why it has to have bounds on it. Got a table here. And on the and here's my unit circle. I've got radians on the leftmost column, and then the cosine x, which is the x coordinate. And, we can look at zero radians right here. That's coordinate of 1 for the x right there. I could look at pi over 3. Here's pi over 3. And the x-coordinate is 1/2. And there it is, 1/2. Now, if I reverse everything, all I've done here is I just rearrange, instead of cosine pi over 3 equals 1/2, it's cosine negative 1, arc cosine, 1/2 equals pi over 3. Same thing as pi. If the radian's right here, pi, and the cosine of pi is negative 1, as we see right here on the left, then cosine negative 1, or the arc cosine negative 1, would equal pi. We're just reversing it. But why aren't they always functions? Let's look at this. Remember, a function, as I have on these two ovals on the left, every input can have only one output. They can go to multiple outputs, such as at negative 3 and 3, negative 2 and 2, negative 1 and 1, and the 0 goes to 0. And they go to the negative 3 and positive go to the same output, negative 2 and positive go to the same output for negative 1 plus positive 1. This is y equals x squared. And if I look at my radian, my cosine, my 0 radians goes as cosine of 1. And pi over 6, remember, this is the x-coordinate, goes to square root of 3 over 2. And also what's interesting, square root of 3 over 2, 11 pi over 6 goes to square root of 3 over 2. And that's why I've kind of deleted it right here, because this, I put the ones in red. I really don't need these. They are duplicates. So I can just go to 1. And every one on the radians has only one output going out. So this is a function. And as we saw with a y sine wave or cosine wave, it's a function. It only touches once. But what happens is now remember we had multiple. Every input only had one line going to output, and the outputs could have multiple lines coming to it. We reversed everything. So now we got the inverse of this, cosine negative 1x or the arc cosine goes to radians. And what's happening here is my cosine, we looked at this one, cosine negative 1 square root of 3 over 2. Now we got pi over 6, but here's pi over 6 here. And then I got square root of 3 over 2, 11 pi over 6. Which one does it go to? This one or this one? And that is why we get it going through multiple places. We could look at cosine of 0, which is pi over 2 right here. That goes to pi over 2. But then it also hit right here, cosine of 0 goes 3 pi over 2. Which one does it go to? So that's why the arcs, arc sine, arc cosine, are not functions. They have multiple outputs coming from the same input. Now, if I set a boundary here, and what I mean by a boundary, let's look at this. From -1 for the x-axis, that's my x right here, and then from, I'm sorry, that's my -1 right here, and then my y goes from 0 to pi, and you see this here, it goes halfway around, but not quite, because it can't be exactly at that point. But if I have a defined boundary here where the lower limit is -1 pi and 1 comma 0, which is from 2 pi to pi, or 0 to pi on the circle, it is a function, but only within certain upper lower boundaries. Same thing with sine to -1x, or arc sine. I've got all my radians up here, the sine x, and then the arc sine of the sine -1x. And same unit circle here. We're just looking at the y coordinates, such as here pi over 2 has a y coordinate of 1. Here's pi over 2, y coordinate of 1. Pi over 4 has a y coordinate square root of 2 over 2. Y over 4, y coordinate square root of 2 over 2. And interestingly enough, if I go over here, 3 pi over 4 also has a resulting y of square root of 2 over 2, because they're going across here. It's the same height, same vertical. But if we reverse them with the arc cosine, and this is, and by the way, this is obviously, this is a y equals sine x. I can put a straight line through there. Straight line through there only touches one point. It is a function. And we can see here, I only have one output. And what I've got here, these are duplicates. And if I'm just looking at, is it a function, every input has only one line going to an output. Now, 7 pi over 6 and 11 pi over 6 both go to -1/2. And I was looking at pi over 4 goes square root of 2 over 2, and then 3 pi over 2. I'm sorry, yeah, 3 pi over 4 goes square root of 2 over 2. And that's just a duplicate, so I just erased them right here. So I just put it right there. So, but every input, the radian in this case, has only one line going to an output. So it is a function. However, just like with the arc cosine -1, when I reverse it, I've got multiple outputs going to the same input, or reverse. 0, the sine of 0 is 0. It starts at the very beginning of the circle here. But it also is at pi. So which one is it? When I have sine 0, does it go to pi or does it go to 0? Same thing as pi. Arc sine, or sine -1, square root of 2 over 2, goes to pi over 4. And also, it goes to square root of 2 over 2 here. Also goes to 3 pi over 4. So, which I have the line right here. Which one does it go to? And we don't know. And that's why it is not a function. I got multiple lines from input going to an output. Now, interesting thing, arctan and tangent of x will have unlimited domains, but for different reasons. I'm going to show that in a moment. Here's the radians, here's tan x, here's arctan x on the very right here. And I want you to notice here, we've got some undefined areas. Pi over 2, 3 pi over 2, because tangent, it's terrible, I'm sorry, equals sine over cosine. And if I go to pi over 2, right here, my cosine, which is the x-coordinate, is 0. And I cannot have 0 in the denominator. 3 pi over 2 also have 0 for the cosine, which is going to make 0 in the denominator. So it cannot exist. It can approach it, but can never exist. So it's interesting. I still have one output. One line from each input going to an output. And we get this unique graph because it can never be at the undefined area right here and right here. And here's pi over 2. There's an asymptote there. And here's 3 pi over 2. And if we go around the circle, it'd be negative pi over 2. And keep going to negative 3 pi over 2 would be out here. So we keep getting this because of that. Once it's 9 degrees to 270 degrees, it cannot exist. And it can exist, but only from negative pi over 2 to pi over 2, which means I can have tangent of 0 right here. Here's pi over 2. Here's 3 pi over 2 right here. So where it's undefined, and that is where the x can equal 0. So basically, it cannot exist beyond pi over 2 and negative pi over 2. And that is because it is at 90 degrees, which has a cosine of 0 and a cosine of 3 pi over 2. And it can only exist within, like I said, negative pi over 2 and pi over 2. And remember, these square brackets means it can go anywhere between negative pi over 2 to pi over 2. But it can never be at pi over 2 negative pi over 2, because that is what doesn't exist. It can infinitely closer and closer, but it can never go to pi over 2 negative pi over 2. It just, and if you graph it here, there is an asymptote here at pi over 2 and negative pi over 2.